All right, everyone, this is Nick Jacobs, math instructor at Yavapai College for Math 097 Intermediate Algebra. And this is the lecture for section 6.3. And I'm going to go ahead and share my screen and get this going for us. All right, so section 6.3 is on factoring trinomials in the form of ax squared plus bx plus c. Last section, we had just x squared plus bx plus c. So the only difference here is now we have a coefficient of the a out in front, which just makes things a little bit more complicated, but I think we'll be able to handle it. So let's go here. Some objectives are factoring trinomials by grouping and then factoring by breaking up or splitting the middle term. Usually I call it splitting the middle term. And there's different ways to do that as well, but that's just the way that I prefer. So we could factor this by grouping, which is basically what I'm talking about. We're going to split out the middle term. So if you like having steps here, you can definitely do that. Usually I don't like say, okay, step one, we're going to do this. Step two, we're going to do that. I just kind of do it and you guys can follow along. And if you want to look back at the steps, look back to see what we did, we can definitely do that. Okay, factor each trinomial. So I'm going to try and do these one at a time, I believe. Yep, I'm going to do A on this page, and then I'm going to do B on the next slide. All right, so let's factor these. So again, the only difference is I have a leading coefficient here other than 1, and I cannot take out a GCF of this to start. That's kind of what we did at the end of last section. We took out a GCF and we ended up with the GCF or the common factor on the outside and then a trinomial on the inside, which had a leading coefficient of 1. Not the case in this section. So let's go ahead and start these. So what I'm going to do is I'm going to multiply this number with this number. So assuming this is in descending order, right, of basically our powers here, x squared, we have x and then a whole number. We're going to multiply the 2 and the 15. Okay, so 2 times 15 is 30. Okay, and basically what I'm going to do now is sort of what I did last time in the last section. So I want factors of 30 that add or give me a sum of 13. So I know my factors of 30 are 1 and 30. Oops. 1 and 30, 2 and 15, and 3 and 10, and 5 and 6. Well, the only pair that add to 13 there are the 3 and the 10, and they both have to be positive. So I would know that 3 plus 10 is equal to 13. And that's what I mean here. I'm going to split, and I'm kind of going to do this. I'm not going to write this every time, but I'm going to split up 13x, and maybe I'll do that over here. I'm going to split up 13x into 3x and 10x. Okay, so I'm not multiplying those, but I'm splitting them up into those because they add to 13x. Okay, so that's what I'm doing here. And if you don't know what I mean, if it doesn't make sense, bear with me. Hopefully it will in a little bit here. So I'm splitting up 13x into 3x and 10x because I know that those add, that's a 10x, those add to 13x. And now what I can do is what we did last time, is the factoring by grouping. So I can group these two together. So our first two terms and our last two terms together. And then I can take out common factors of those or GCFs of those. So 2x squared and 3x, our common factor there is x. So I factor that out. And I'm left with a 2x plus 3. And right here I have 10x plus 15. I factor out a 5 and I'm left with 2x plus 3. And we notice here, remember from grouping, that are looking for the common factor now once we're all done with that. And that's the 2x plus the 3, excuse me. And then I take that out, I factor it out, and I have 2x plus 3 times x plus 5. And that is my solution. And again, right, we can check this by FOIL. So I take 2x times x. 2x times 5 is 10x. 3 times x is 3x. And 3 times 5 is 15. And then I combine like terms. And look at that, I'm right back to where I started. So the check is good. I did it right. Okay, this one, I'm going to factor question B. So instead of the two numbers being positive now, the two numbers are going to be negative, and some of these are just a little bit different. So I have 12y minus 5y minus 3. So again, these are in descending order. I have basically our greatest degree term, our next greatest degree, our last greatest degree. Again, degrees of term is just based on the exponent. So, I mean, if I gave you this question and it was like negative 5y minus 3 minus 12y squared, or sorry, plus 12y squared, you would have to put that in order, okay? Put that in order from greatest degree term to lowest degree term. So I would just move the 12y squared out in front. Then I can do this trick here. So I'm going to take the 12 and the negative 3, multiply those together. So 12 times negative 3, and that is negative 36. And then I need factors of negative 36 that add to negative 5. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Okay, and 6 and 6. Which one or how can I get a negative 5 here? Well, they have to multiply to be negative 36. So one of these has to be negative. And it looks like this is going to be the case. So it's going to be a positive 4 times a negative 9, multiplies to negative 36 and adds to negative 5. So I am going, these guys here, 4 minus 9 is negative 5, or 4 plus negative 9 is negative 5, but that's how I'm breaking up the negative 5y. So it's going to be 4y and negative 9y is negative 5y. So maybe that makes a little bit more sense now. So I have 12y squared. I'm breaking up the negative 5y into what I just did. Plus 4y, oops, not minus 5, minus 9. You notice on the last video I did figure out what I did wrong. I just copied down something wrong. That happens to everyone. But if you figured that out, you know what to do. And then, okay, so I just broke up the negative 5y. Now I'm going to group it, right? So I group these two together and I group these two together. I'm kind of skipping a step there without writing it out again. Hopefully you can follow. And then I take out the common factor of 4y in this one. So I have 3y plus 1. It's a good placeholder there. And then I keep the negative sign. I take out the negative. Let's see. Yeah, negative 3. And I have a 3y plus 1. And there we go. And if I distributed that, it would give me what I originally had here. So let's see here. Actually, I think I'm making a mistake. If I group this together, I still want this to be negative 3. So actually this would have had to be a positive. I'm like thinking in my head here, what am I doing? So yeah, so that would have had to be a positive. Yes, that's the only thing that I did wrong. Okay, so this would still be 3y plus 1. Okay, now I have those, and then I can just group, or sorry, put those common factors together. And so I have 3y plus 1, and then times 4y minus 3. And again, you should be able to FOIL that out, and it should check. All right, let's try to factor this trinomial. So 3x squared plus 9x plus 4. So again, this is in descending order. I'm going to take the 3 times the 4, which is 12, and I need factors of 12 that give me, or that add to a positive 9. Is that possible? I have 1 and 12, 2 and 6, 3 and 4. Those all multiply to give me 12, but I'm trying to make them to add to 9. Does that work? No, none of these options are possible. If and when that happens, and we had one of these last time, we know that the trinomial is prime. So I can't do anything else. That's all it is. All right, quick check here. A student was told to factor 2x squared minus 4x minus 6. The answer they got was 2x plus 2 times x minus 3. Should they get full credit? Well, is that wrong? So that is 2x times x is 2x squared. 2x times negative 3 is negative 6x. 2 times x is 2x, so negative 6x plus 2x is negative 4x. And then 2x times negative 3 is negative 6. So that is correct. But should they get full credit? Why not? Well, we notice that in this polynomial here, 2x plus 2, or this factor, I can still take out a 2 from these. So if I do that from this first term here, or this first polynomial, if I take out a 2 from 2x plus 2, I have 2 times x plus 1, and then times x minus 3. So this is actually the complete answer. So really, no, they should not. And why? Well, because you can still take out a 2 from this. So when you think you're done factoring, make sure that you cannot factor anything else out, any common factors. All right, let's try to factor this trinomial. So this is what I'm talking about with it's not in order, right? So I want the greatest degree term, or the term with the highest or the largest exponent first. So that would be negative x squared. Then I want the negative 6x. Then I want 16. Now I can factor. Well, this case, we notice the leading coefficient is not 1. Okay, it is something besides 1. Well, it's really negative 1. Okay, well, if anytime I have a negative 1, I can factor that out. And that's the trick here, because I don't want to factor this by grouping. Okay, I just want to keep this as, or I want to try to get it so the leading coefficient is 1. And now it is. So I took out a negative 1. Negative 1 times x squared is negative x squared. Negative 1 times positive 6x is negative 6x. Negative 1 times negative 16 is positive 16. That checks out. Now I'm going to factor this. Well, the leading coefficient here is 1. Okay, it's not something that we've been doing in this section. It's something we did in section 6.2. So now I can just take 1 times negative 16 is negative 16 and find factors of that add to 6, which would be negative 2 and 8. Negative 2 and positive 8. So this one would just simply be x minus 2 and x plus 8, and then negative 1 on the outside. And that's it. And again, you can check this. You can distribute the negative 1 in here and then get an answer and FOIL that with x plus 8. And it should give you this guy. All right, I threw in a bit of a doozy here for the last example. I wanted to just give us a little bit of a challenge here. This was, you know, this is a challenging section, but I just, you know, if you want to try and pause the video and try to do this on your own, feel free. Okay, try and do this. So in this case, I want to find the GCF first. Well, what is the GCF? Okay, what is the greatest common factor here? Well, I have three numbers, three leading coefficients that are even. And I also have one that leads to be a negative. Now, as far as the degree of these, I don't have to worry, because when we find greatest degree, I add the degrees. Well, these are all degree 6 because I have 3 plus 3 is 6. Adding the exponents, 2 plus 4 is 6. And the degree of x is just 1. So 1 plus 5 is 6. So it is pretty much in order. But I know there that I can at least take out a -2 because they're all even. And I took out the negative because I don't want the leading coefficient to be positive when I factor this. And then I have an x to the third, x squared, and an x, so I can take out an x. And I have a y to the third, y to the fourth, y to the fifth. So the smallest one of those is y to the third. When we're factoring the with the variables, we always want to take out the smallest one. So we wouldn't factor out an x to the third. That doesn't make any sense, okay? Because this one, I don't have that many x's. Same with x. And I wouldn't factor out a y to the fifth because I don't have that many y's. And same with this one, okay? So I'm going to factor out -2x y to the third. And then let's figure out what we have left. So I took that out of this first term. So taking -2 and -28, I would need a 14 to multiply those to get me to -28. And then I have an x squared, and I already took y to the third. So that's good. This sign's positive, so I need my next sign to be negative. Negative times a negative is a positive. And then I took 2 from 26, so multiplying, I would have a 13 there. X to get me to x squared, and then I took 3 of these y's, so I have 1 left over. And then I have plus, because I want this next sign to distribute to give me negative. So plus, right, negative times a positive is a negative, plus 3, I took the x, and I took 3 of the y's. Okay. Now I'm going to leave this alone, and I have a trinomial that has a leading coefficient this time other than 1. So it's 14. So I take 14 times 3. What is that? 42. And then I need factors of 42 that add to -13. Well, what are some factors of 42? Well, I know 6 and 7. And I can just make both of those negative because those multiply to give me +42 and add to give me -13. So I'm just going to leave this guy out here. And then I'm going to split the middle term into the -6 and -7. Now, the only case here is that I have an x and a y, so I need to include those, right? Because -6xy and a -7xy add to give me -13xy. And now, oops. All right, let's let me just erase that. That's an x. Oops. I want this to take too long. I'm just trying to copy that. And then I'm going to group these guys together. So let me incorporate a parenthesis or a bracket there. So I'm going to group these. So this is going to be a bracket. This is a bracket. And I'm going to have this is in parentheses and this guy is in parentheses too. So in this one, I can take out a 2x and I'm left with 7x minus 3y. And this one, I'm left with a y. I can take that out. And this is a 7x. And this is going to be a -3y. And now, and I don't expect you to do it that fast, but if you want to pause and see why that's true, you can. And then now in the brackets here, I can combine, oops, I'll write the factors that I'm combining first. So 7x minus 3y, that's a common factor. So I'm going to factor that out. Oops. And then leave the other ones in there. And then again, you can also write this without the brackets at the very end. So negative 2x y to the third times 7x minus 3y times 2x minus y. And that's it. That's your answer. So at the end here, I just kind of put in a little signs chart. And this was really this was the way that the book taught it, with factoring by FOIL backwards. That's not the way I teach it. I teach it where we split up the middle term like I just did. So, but I had to learn these I just, had to recognize these when I was in school. And if that's how you did it, and if that's how you learned it, that's perfectly fine. You don't have to split the middle term. Sometimes it's good to know these. And if you want to look at those examples in the book and those videos, if you watch the Pearson videos, they might teach it a little bit differently than I do, and that's perfectly okay if you are more comfortable with factoring by FOILing in reverse. So that's it for this video. So I will see you next time for section 6.4. Have a good one.